All right, this next tab is the biggest one. It has 5 subtabs because it's all the t-tests. So I'm going to pull this file over. All t-tests. And there are 5 of them. So let's add it to the main tab. So we're going to add in all t-tests. And we're also going to add in the bullet that we can select in the app. All t-tests. Underscore all the t-tests. Okay, that ought to do it. So let's launch the app now. Streamlit run app.py. Okay. And at some point we're going to upload this online. I'll show you how to do that. Once we're done working, then I will upload it online and we'll access it from there instead of locally. So all the t-tests is the new tab. You see how there are 5 sub-tabs in here. The first one is a one sample data. So we will pull in data from our Google spreadsheet. The bivariate data, same one that we had on the quantitative stats. When we do a one sample test, we can pick a variable, either a numerical variable, either height or weight. And then we can do gender, and then we can do males. We have to narrow down into one group of quantitative data. And you can filter it down to just everybody's height or group C's height or whatever. But you can drill down onto a single group of quantitative data. Now, once we have that data, we test to see if the data is normal enough to do the test. Here is the description of just the data that we've drilled down in on. The height of group C, 25 of them, blah, blah, blah. Then we can do a test. We give it a null hypothesis, a left-tailed test, two-tailed test, right-tailed test, degrees of freedom, all that stuff, and then the p-value. And then down here we have a confidence interval for where our data is. Okay. Then we can do the same test, but now instead of with data, we're just using statistics. So summary statistics of the data. How big is your sample size? What's the X bar of the data? Standard deviation of the data, and then you can run your null hypothesis from that. The next one is paired sample data. So I have a set of data in the spreadsheet for paired, like what was the data before and after for each person, your before data, your after data, and then you can drill down in just like we did on the others. Then you can do your null hypothesis, and then left tail, two tails, right tail, and same information there, and there's your confidence interval for the data. And then 2 sample data, so independent samples. You can compare two groups to get against each other if you wish, something like that. Height, weight, groups, males, females. So you want two groups and you're going to compare them to each other. And then you can do a null hypothesis, left tail, two tail, right tail. Also, can you assume that the variances are equal or not? That's when you're computing the critical value. That matters. And then two samples based off of summary statistics instead of straight up data. Same information here, null hypothesis, left tail, two tails, right tail. Are the variances equal or not? If you do equal variances, of course, that is much simpler degrees of freedom than if you assume not. That's the differences here. And then down here you have your margin of error, or your confidence interval. All right, so those are the 5 tabs. So this is the biggest one of all the tabs. It has the most code involved. So let's take a look at the code, all the t-tests. Here's all of the libraries that we're pulling in. It's still one great big function. You can see over here how long it is. It's quite long. I'll blast through this as quickly as possible. But let's, and a lot of the code is repeated for all 5 tabs. So first, oh, it doesn't look like we have a title going on for the t-tests. Yeah, there's no title. I guess I could put a title on there for each one. But the sidebar has all 5 tests. So if it's a one sample data, we could put a title on there. Let me think about that. One sample data. Oh, this one does have a title. That one doesn't. So only the first one has a title. Oh, that paired has a title. One sample stats needs a title. Two sample stats needs a title. Alright, see if I can remember to put those in. Alright, so one sample data, I've got 3 columns. Grab the spreadsheet, the name, we're going to do the bivariate tab on the Google spreadsheet. We pull it in, look at the columns, some are numeric, some are non-numeric. We'll have those columns. In the column 2, that's where we're splitting out the data, drilling down on certain data types. So the quantity, categorical variables, you decide which variable you want to work with. And then in the third column, that's where we're going to do our QQ plot from the Penguin library, after we've drilled down on the data set that we want to use. So this code right here is where I'm drilling down on filtering down onto which category or which piece of the data set I want to use. So filter, filter, filter. You can pick, I want to do genders, I want to do females, whatever. That drills down into this data set, the filtered data set, and then it does the QQ plot on just that data set. Put some titles on the QQ plot, and then gives me a value, a p-value for that that QQ plot. And then down below, 3 columns, 3 new columns, and they all have different widths, a 1 size, a 2 size, and a 3 size. So I've got a null hypothesis, alpha value, and we're going to do left tail, 2 tails, right tail. I take that data set to get degrees of freedom, and that's how I come up with my p-value and my data that I'm going to show. I create the graph, -5 to 5, with the t and the y values, and then I plot it with a line. That's a vertical line there. And then if it's a left tail, I'll show it with that. If it's a 2 tails, then I'll go from there and there to there. A negative value and a positive value of that t-score. If it's a right tail, then I'll just do the right t-score and to the right. And then I grab the data frame of all of those data so I can display all of those values all the way down to the p-value, and then write it. And then in the third column is where I'm going to plot the graph. And then, so that's the end of one sample data. One sample stats is very similar. Paired samples, grab the Google Sheet data, decide which things I'm going to compare to each other, and then in the second column, I decide what's the before, what's the after data, and then I'm going to subtract the after minus the before to get the difference in the data set. And then the difference is what I'm going to run my test on. So here I'm drilling down onto what my categories are going to be. And then in the third column is where I'm going to do the QQ plot of the two things that I picked. Down below is where I'm going to do the test on the difference of the two datas. And let's see, right tail, 2 tails, yeah, left tail, 2 tails, right tail section here. Display all the data all the way to the p-value. And in the third column is where I'm going to graph the t-curve. Then I go down to 2 sample data. So I have I grab the Google spreadsheet. I decide what my 2 independent samples are going to be, like males compared to females or whatever, group 1, group 2. And then for those 2 groups, I want to, I'm going to do the t-test on the difference between the 2 groups. So the difference of the averages of the 2 groups. And so as I'm grabbing that data, I do the QQ plot for both groups separately. And then down below in the bottom group, I do this is where the statistical test is going to come out. If the variances are equal, I just take the 2 sample sizes minus 2, 1 each. If it's not, if I can't assume equal variances, then I need to do degrees of freedom based off of this crazy formula. And then I can get my t-score based off of that. And then I decide if I'm going to do a left tail, a 2 tail, or a right tail test. Grab my data frame all the way out to the p-value, and then I graph what that would look like in a t-distribution. And then the last one, 2 sample stats. So instead of grabbing out of the data frame, I just have statistics of the 2 groups, sample size, the average, and the standard deviation of each group. And then I do the math on just that information. And then I can decide left-tailed, 2-tails, or a right-tailed test. And then I end up with a graph of that t-distribution. So that's all 5 of those things. They're all very similar. Oh, I forgot to put a title on one sample stats. All right, let's go find that. One sample stats. There's paired. All the way up at the top. So here's one sample data. So I'm going to grab this and I'm going to go down to one sample stats, which is here, and I'll put it in the first column. One sample stats. And then the other one that needed one was, where it has it, 2 sample stats needs a title. That's way at the bottom. Two sample stats. Okay, let's refresh this. All t-tests, one sample stats now has a title, and 2 sample stats now has a title. All right. Okay, let's send all of our changes back up to GitHub. Update. Commit that back up to GitHub. And so now we're all set. We have 5 tabs. All right, let's stop there.